Now let's go through some examples of actually writing the formulas from the ions. The first thing we have to do to determine the formulas from the charges is to identify the charges on each of the elements. In this case, we have sodium chloride, and when I look at sodium, it's in the first column of the periodic table, so it has a +1 charge. And when I look at chlorine, it's in group 17, so it has a -1 charge. Now I'm going to look at how I form that compound. So I take sodium with my +1 charge. Usually we don't include the one I did here just for an example. Same thing with chlorine, we have our -1 charge. Now I'm going to crisscross down those numbers, and I'm only bringing the numbers down. I'm not bringing the positive and negative signs, just the numbers. And I'm going to rewrite that as Na1Cl1, 1 sodium to 1 chlorine. Because they're both 1, I don't need to include that in the formula, so we write that as NaCl. Let's look at another example with sodium and sulfur. In this case, we're going to see something that is not 1 to 1. We have sodium, which has our +1 charge, and sulfur, which has a -2 charge as an anion. Again, I'm going to write my sodium and sulfur with the charges. I'm going to crisscross down, but I'm not going to bring the charges down, just the numbers. And I get Na2S1, which I rewrite as Na2S, because we don't put the 1 in the formula. If the subscript is 1, we always omit it. Crisscrossing the charges helps us figure out how much of each ion we need. We can also check this by looking at the charges. So we have 2 sodium, each with a +1 charge, plus 1 sulfur with a -2 charge, and when we add that together, we get 0. Overall, the charge on an ionic compound is neutral. Let's look at the example of magnesium sulfide. Magnesium has a 2+ charge, it's in group 2. Sulfur is in group 16 and has a charge of -2 when it forms an ion. I write both ions with their charges and then crisscross down. And when I do that, I get Mg2S2. Remember that when we're looking at ionic compounds, they exist as an array, and we're only worried about that ratio between the cations and anions. With molecular compounds, we never reduce or simplify the ratio because they exist as discrete molecules. Mg2S2 is a ratio between ions, so we can actually simplify that down to Mgs. When we check to make sure we have a neutral compound, we see that we have 1 times 2 plus 1 times 2 minus, and that equals 0. What is the formula for the compound formed from calcium and phosphorus? First, we need to determine the ions that form for each of these elements. Calcium 2 plus and phosphorus 3 minus based on their location in the periodic table. We crisscross down and we get Ca3P2. We can't simplify that down. That is the simplest ratio between those two ions. We have 3 times 2 plus 2 times 3 minus, and overall we have a neutral compound. So C is our answer. When we start looking at polyatomic ions, we sometimes have to use parentheses in the formulas. For example, barium hydroxide has the formula Ba parentheses OH close parentheses 2. Barium has a 2 plus charge. The hydroxide ion has a -1 charge. When we crisscross those down, we get BaOH2. We need the 2 to be outside the parentheses because it indicates that there are 2 OH groups, not 2 hydrogens, not 2 oxygens and 2 hydrogens, but 2 OH groups. For sodium sulfate, we have Na plus and SO4 2 minus. When we crisscross down, we get Na2. It doesn't need parentheses because that's a monatomic ion, and SO4. Because there's only one sulfate, we do not use parentheses. Only use parentheses when they are needed. There's only one sulfate group, so no parentheses here. For aluminum sulfate, we have Al3 plus, SO4 2 minus. We crisscross down, and we get Al2, SO4 3. Notice that the 4 doesn't change. That 4 belongs to the sulfate group as SO4. We never change the formula of the polyatomic ion. We can only put it in parentheses and put a subscript outside it, in this case 3, in order to get a balance of charge. Let's look at some more examples. Calcium nitrate. We have calcium, which has a 2 plus charge. It's in the second column of the periodic table. Nitrate, and we know this just from learning them, NO3 with a -1 charge. We crisscross down, just like we did with our monatomic ions, and we get Ca1 NO3 2, but we're going to omit that 1 by the calcium because we don't write 1s in formulas. Notice that we did not change the formula of the NO3. It stayed exactly as it was, and we simply put in parentheses and put a 2 outside the parentheses to indicate that we have 2 of the NO3 or nitrate groups. Just like with our monatomic ions, we need this to be a neutral compound. We have 1 2 plus charge with the calcium, 2 -1 charges with the nitrate, and those sum to 0. Ammonium sulfate is actually 2 polyatomic ions coming together to form a compound. Ammonium has the formula NH4 with a +1 charge. Sulfate is SO4 with a 2 minus charge. We crisscross down, and what we get are NH4 to SO4. Notice that we use parentheses around NH4 because we needed to indicate that there were 2 of them, but did not use parentheses around SO4 because there is only 1 of them in the formula. Again, looking at our charges, we have 2 with a +1, +1 times -2 from the sulfate, and when we add those together, we get 0. What we can also do is identify the charge on a transition element based on a given formula. What is the charge on iron in FeCl2? We have FeCl2. We know that iron is a transition metal, which means it can have multiple different charges, and we have to have other information in order to identify that charge. Since we don't know the charge on iron, we're going to label it as X. We know that chlorine has a -1 charge because it's in group 17 of the periodic table. Now we can solve for the value of X. We have 1 iron, which has a charge of X, plus 2 chlorines, each with a charge of -1, and together those must sum to 0. So X minus 2 equals 0, X equals 2 plus. Therefore, the charge on iron is 2 plus. What is the charge on titanium, in TiO2? We don't know the charge on titanium, so we'll label it as X. We know that the charge on oxygen, based on its position in the periodic table, is -2. We can set up our equation. We have 1 with a charge of X plus 2 ions with a charge of -2 each, and those have to sum to 0. X minus 4 equals 0, so X equals 4 plus. What is the charge on zinc in zinc sulfide? We write out our formula, ZnS. Then we list the charge of zinc as X because we don't know it because it's a transition metal. We know the charge on sulfur is -2. Now we can set up our equation. 1 times X plus 1 times -2 equals 0. X minus 2 equals 0, so X equals 2 plus.